Okay, everyone, welcome to OWASP London chapter. Please do grab a drink and take your seats. We are live streaming this event live on YouTube, on OWASP London YouTube channel. As you can see tonight, we are in this awesome venue, Thought Machine, and this event is, the food and drink is sponsored by Phoenix Security. There will be pizza and more drinks coming a bit later. So for those of you who don't know me, my name is Stepanyan. I'm OWASP London chapter leader. We have two more leaders of OWASP London chapter, Andra, Lezza, and Sherif Mansour. Actually, for health reasons, they cannot be here, but you will see, you may have seen them at a previous event, you will see them at future events. If you are going to put anything on social media about tonight's event, Twitter, LinkedIn, whatever, please do use hashtag OWASP London, and you can mention us, we're OWASP London on all social media. Not Snapchat. Right. So just a quick reminder about our code of conduct. We are a very friendly community, so we want to make sure that everyone's enjoying these events. So please behave responsibly and be respectful to each other. And if something that you want to report, please do come and speak to us. So agenda for tonight, I'm going to talk about the about OWASP, about latest news and conferences which are coming up. Then we're going to have Anant speak about code dependencies and is that actually enough. Then we're going to have a break, which will be combined with Francesco's book signing. He brought some books, so if you want to get a book, you can actually get it signed by the author. He's there. Then we're going to have Francesco actually talk to us about AI second threat-centric approach on vulnerabilities, because Francesco has done a lot of work on vulnerability research. And then we're going to have a raffle and prize giving. And then we're all going to go to the pub. And this is the name of the pub, the Marquis Commonwealth. It's literally like 2 minutes walk away from here. I'll show you where we're going, but just in case, if you want to know the pub's name, that's where we're all going for drinks afterwards. Right. How many people are here for the first time? Show hands. Wow, that's like almost half of the audience. So thank you very much for finding us. I'm always happy to see new faces. I have no idea how you found us, but this is how to find us, because you can first of all, find us on the OWASP London official webpage, because we have a page on the official OWASP Foundation website. We are on Twitter, on Facebook, on Meetup, on Eventbrite, on LinkedIn, on Blue Sky, and of course we're also on YouTube, and we are live streaming on YouTube right now. And our channel is OWASP London, so you can watch the recordings of all our previous talks as well. And if you follow us on all these channels, you make sure that you don't miss the next event. We also have the old-fashioned mailing list. So those of you who don't like social media but would like to get an email notification about next event, you can go to our webpage and click on sign up for the mailing list and get an email message. Right, we have a raffle prizes tonight, which are sponsored by Phoenix Security. So we have this 3 awesome Lego cars, which are here behind me. So we have Lamborghini, Bugatti, and Ferrari Formula One. So I hope you all signed up. If you have not signed up yet, there are pieces of paper, QR code that you can scan, also on the screen. But the prizes can only be won by people who are here in the audience. We will have a wheel of names, and this is why you also need a sticker with your name on it, because we will check that the person who won the prize is actually the person who is present here in the audience. Right, I've got a short video, a 1-minute video about OWASP. Let me see if the audio works. Sometimes there's an echo in it, but let me see if I can play this video. And let me just get it sorted.
OWASP is a nonprofit that stands for the Open Web. OWASP is access to
Right. So let me mute my microphones. The echo is gone. Um, very quick slide about OWASP in the UK and Ireland, because obviously we're here in London, but I want to give huge shout out to all the other chapters all around the UK and Ireland. So if any of these cities are closer to your home, or you have friends who are into development, security, application security, DevSecOps, there are all these choices for them to attend events at all these cities all around the UK and Ireland. Now, OWASP membership benefits were mentioned. We also have a few others. So for example, AppSec Phoenix, Phoenix Security, as it known, they do provide version of their platform to OWASP members as well. So you just need to sign up with your OWASP.org email. And we have other sponsors such as Ubic and Security Journey, which provide their platforms to OWASP members. And also we have Checkmarx Code Bashing, which is another security training platform that, again, if you become an OWASP member, you can access absolutely for free. All you need to do is just sign into your OWASP.org Google Workspace account and use single sign-on to log into this platform, which provides lots of training courses. Now, as mentioned, OWASP membership, OWASP has a paid membership. You don't have to be a member to use any of our resources. Come to our meetups. This is all free and available. However, if you want to become a member, first of all, to support our foundation, because we are a non-profit, but also, of course, to get advantage of all the benefits that we listed. The membership costs US $50 per year for individual. For students, it's $20 US per year. And if you represent a company and you want to become a corporate supporter, there are corporate supporter packages available as well. So please do explore that on OWASP.org. Now, obviously, you heard of all of the benefits of OWASP membership. There's one more benefit, so particularly interesting with people who are new here tonight, is that I have a stash of this vintage OWASP member stickers with our old logo, right, which looks like this special button. And if you become an OWASP member tonight, you can just go to owasp.org and then click on the join button, and you sign up tonight and show me the confirmation that you've become an OWASP member. I will give you the sticker, and you can actually see the sticker here on my laptop. So yeah, that's one of the advantages of becoming a member. Of course, we are a non-profit, but we are supported by lots of organizations. There are too many to put them all on the screen. Our OWASP London chapter is actually quite lucky. We have quite a lot of chapter supporters. And if you represent a company who wants to support us, you want to see your logo on the screen at every single OWASP London chapter event, please do come and speak to us and see how you can become a corporate member. There are also a few people who support us by providing their office space. So these are the logos of all the organizations which provided us with their space. And you can see that Thought Machine, this space is actually hosted quite a few of our events before. And I'm not sure, we have Jack in the audience to come and talk about the, yes, hey, hi Jack. So we have Jack from Thought Machine who's gonna tell us a little bit what this company does and about a job opportunity that they have.
Thank you. Has anyone actually ever heard of Thought Machine before? Oh, right. The employees in the crowd, thank you for that. But everyone else that hadn't, Thought Machine sounds like an AI company, but we're not. Primarily a core banking product. And as we've hosted this, it would make sense to sort of advertise ourselves and to sort of show the job opportunity that we have, as this is a security meetup. So we are looking for a security engineering manager. We have QR codes on the tables over there, and they look like I got handed this. It's beautiful. Just give me one sec. QR code, nice and easy. Just put your phone to it and see the job description, see if it fits, and if you're interested in it. Yes. So the team overall, I'll preface this that I am going to be adjacent to whoever gets this, but I'm in threat operations. I joined Thought Machine 2.5 years ago. I was previously in a consultancy, and then I joined Thought Machine. And the team is responsible for quite a lot of different things. The product is very large in the sense of huge volumes of data. And obviously, when you're looking after people's mortgages, it's a SaaS product. There is things that you definitely have to think about. If you're looking for a very intense, in some ways, but rewarding job, then I think Thought Machine is definitely for you. The team is very collaborative. So in threat operations, we have loads of alerts and security incidents and things like that that we attend to. And then security engineering are more based on things like code review, SEMGREP, SaaS products, vulnerabilities, and engineering pipelines for logging and things like that. So depending on whether you like security engineering or threat operations, you might be interested in the role. The organization overall is really transparent. I really like Thought Machine overall. I sort of have to say that I'm on the stage, but when this stage is specifically designed for every Friday, we have a CEO or someone have a conversation about how the company is doing, and they will bring out a spreadsheet and talk about how the company financially is doing, very transparent. And also, you can have a drink, you can have soft drinks. There's loads of benefits. I'm sure if you go on the QR code, you'll see loads of good things. The team culture is really nice as well. I feel quite, I have my own desk. There's no hot desking or anything like that. You have your own space. It's nice and calm. I guess that shows a little bit about me in the consultancy. Lots of hot desking. But I do think that Thought Machine really does care about the individual. It is still got that startup culture, but it is a little bit larger. So we've got about 500, 600 employees. Some based in Singapore, some based in New York. Our headquarters is London, where we are now. And I implore you to definitely have a look at if the job profile works for you. And there are many other employees here that should have their, I can see one that doesn't actually, who hasn't got their, well, they've sort of got their badge, but you can notice us. We've got black and white photos. We've got the little bands here, these two over there. And you can ask us questions if you're interested in Thought Machine. Yeah, thank you.
Wonderful. Thank you very much. And thank you for hosting us. Right. So for those of you who are members, you will notice that we now have a brand new membership system, which is called Glue Up. And this is the system for which all our conferences are available, memberships are available, and very soon there will be things like the chapter and project management will be available as well. So it is still being rolled out, so there are a few teething issues. So if you have any problems signing up, please let me know. Generally, it's been fine in the past few months, I think, and we had some good feedback coming from our members. Now, about NFTs, right? So this is my attempt to bring the cybersecurity, security engineering developers into a little bit world of blockchain, which I'm not going to promote, but there's one very interesting use case for blockchain, is that you can get a proof of attendance NFT. There's lots of other NFTs. I'm not going to talk about all the other types, but if you want to prove to everyone that you were here tonight, right, you can come and collect this wonderful NFT. It changes every time, right? I generate using AI a different picture of a wasp doing different things. Right, in the winter, the wasp has a winter hat, and it's like skiing. And during Halloween, obviously it had a Halloween costume and had some pumpkins around it. And now you can see we have a lot of sunshine and London Eye and Big Ben. This is kind of your digital sticker and the certificate of attendance that you can collect into your crypto wallet. And if you don't have a wallet, that's fine. You can just collect it into your email address and maybe introduce yourself into the world of blockchain. And some of our conferences will also have talks about blockchain security, which also is quite an important topic. Now, we do have a merchandise store. So there are a few bits of OWASP stickers and things that are available here. But if you'd like to support us, please do go to owasp.org/store, where you can buy T-shirts, baseball caps, face masks, and lots of other swag. And every time when you buy it, you will actually support us because a percentage of it goes to OWASP Foundation as a donation. Now, upcoming conferences. We just had our conference in Barcelona literally 3 weeks ago. I just got back from it. But we're going to have 2 more awesome conferences this year. So there's going to have OWASP AppSec Days Singapore in September. The call for papers for this conference, unfortunately, just closed. But if you are going to Singapore, or you have any colleagues who are based in Singapore, please to tell them that they can register and attend. And we also have our OWASP Global AppSec USA conference in Washington, D.C. Call for papers is still open, but it is, I think it's closing tomorrow. So if you want to present a talk at any of our conferences, you can do so, or you can go and attend. They're always awesome. I see some people who attended our Barcelona. Who was at Barcelona conference, by the show of hands? Yeah, there you go. I can see a few people. So you know how awesome this conference was. A little bit about OWASP projects. So OWASP has over 250 free and open source projects. Everything is free and open source. We have projects which are standards, guidelines, tools, some lab tools, intentionally vulnerable apps, right? And everything's free and open source, and everything is available for collaboration and contribution. Please, if you go to owas.org/project, you will see that we have 3 categories. So we have flagship projects, we have lab projects, and incubator projects. So the flagship projects are the ones of the strategic importance, and you will probably recognize some of them. OWASP Top 10, of course, being one of the most popular ones. Because AI is the buzzword today, I'd like to remind you that we have absolutely awesome Gen AI collection of projects. So if you go to genai.owasp.org, you will find things like red teaming guide, how to deal with deepfakes, right? How to test AI security properly, right? How to implement AI security in your organizations. There's lots of guidelines available for you. There's also upcoming international standards in AI, which will be based on OWASP standards and guidelines. Please do join us in the AI journey. OWASP is doing a lot of work in AI security nowadays. But obviously not to mention, of course, all the other application security, but let's not forget that AI is still software. So it is still part of AppSec. Now, because there are so many of you in the audience, if you have any questions during the presentation, you can use slido.com/OWASP, and everyone watching online can also use this if you'd like to ask any questions to our speakers. And for those of you in the audience, I will try to run around with the microphone to take questions from you as well. But Slido is another way to get your questions asked and answered. And with this, I would like to present our first speaker, who is Anant Shrivastava. Anant traveled all the way from India to be here with us tonight. And Anant is a very well-known information security professional, speaker. He presented at DEF CON and Black Hat and numerous OWASP events. And actually, if you talk about things like DevSecOps, right? If you just Google Anant and DevSecOps, the first thing which will come up is Anant's a famous talk at Black Hat USA 2019. This is the one that I saw Anant on stage. It's absolutely awesome. So I do urge you to go and check out. And tonight, Anant is going to talk to us about the how to secure software dependencies and what to do afterward. Let's all welcome Anant to the stage. I'm going to stop sharing, and if you share your screen.
Right. Good evening, everyone. So the title for my talk is You Secured Your Code Dependencies. Is that enough? It's contrary to what you would have heard from everyone, where everyone is talking about source code and how you should be securing your source code. I wanted to talk about what are the other things that are there besides the source code that we most probably are just ignoring. So a quick introduction about myself. I go by the title Chief Researcher. The perks of having your own company, you define your own title. So I have a company named Siphnoid Research. I call it as a research-powered, trainings-based company. So all the research work that I do, which is effectively all the time I spend Googling and searching around, I convert that into training material and I then deliver training at different conferences. About 17 years of corporate experience. I've been a trainer, speaker at a bunch of different conferences. I run a bunch of open projects, primary 3 of them, Code Vigilant. Effectively, I wanted to learn how to do code review. So I created a project and I used that to disclose bugs in open source software. Hacking Archives of India, because I realized not many people were tracking who in the Indian community is actually going out and delivering sessions. So Hacking Archives of India tracks all the Indian InfoSec researchers who are presenting in public sphere. Tamer platform is very much focused around Android security. And across all social media platforms, except Snapchat, you can find me as Anant Shri, ANANTSHRI, and anantshri.info is my official domain. All right, so a quick question. How many of you have heard about these 3 terms? Software supply chain security. Nice. Software bill of material. All right. Source composition analysis tool. Some of you may know it by SCA tooling. Yeah. All right. So why all of this started, why we started talking about supply chain security, why we were worried about all of this. Somewhere along the line, incidences like SolarWind, CodeCov, Colonial Pipeline happened where the attacks happened not as a direct consequence, no one directly attacked them, but an indirect attack caused the catastrophe, which is where an executive order by US president was passed on. And in this particular order, SBOM was clearly mentioned. But what was also mentioned was that NIST need to work with the other US government entities to come up with a framework. And they came up with a framework. Now, supply chain security issues are not new. How many of you have been following OWASP for, say, more than a decade? You would have heard a name, usage of known vulnerable component. That is how OWASP used to denote supply chain security issues even before software supply chain security keyword came into the limelight. So the issue is not new. So far as this is the article by Ken Thompson, which I think he did somewhere in 1970s, 1983. That was the lecture that Ken Thompson gave about reflection on trusting trust. And they were talking about how a compiler can be backdoored to always have safe code, but unsafe binary. And the whole idea that they had came from a US military sort of paper that was written in 1970s. So this is not a new issue at all. This is a very old issue. And it's not going anywhere. EU, an agency in EU basically described it as this is going to be the topmost issue in 2030. So we're not even talking about 1 or 2 years, we're talking about a longer time frame. This issue is going to remain there. Across the globe, every government is coming up with something. There's a US regulation, there's an Indian regulation, Japanese, European, UK, every different region is coming up with different regulations. Most of them are effectively saying, have SBOM, maintain good quality hygiene about software development, and that's about it. Now, there's one part about why this is happening now. There's another part about how does the industry reacts to it. And there's a collective failure of IT industry. We do what is bare minimum necessary to be done to get by. And what is asked of us? Create SBOM, follow standard coding practices. So whatever is the bare minimum, if the requirement is 80.000, we will not do 80.001. We will just do what is bare minimum required. So people are creating SBOM. Now there is very much difference between a good quality SBOM versus the SBOM that someone is creating. But having an SBOM does the check mark, so people are happy with it. Now, why this is happening now, why software supply chain is a bigger problem for us now. One, we started with automation of systems. DevOps came into picture. When DevOps and Agile came in, we had rapid build cycles. Now people are able to build softwares faster because the entire process is automated. What happens when you have rapid build cycles? You're able to deploy to production faster. I know of organizations who can actually deploy to production 40 to 50 times a day. We're not even talking about a week. Within a day, 40 to 50 times they can make deployments. When that kind of a rapid process is there, the development pace is also rapid. What that then means is, I am less inclined about maintaining my tech debt. I am more inclined about releasing features. When I'm not inclined about maintaining my tech debt, I would try and find other pieces which I can source in, which is where now the stats say about 80% of our code is actually import statements. We're just borrowing code from other people and then using them in our systems. There is obviously an advantage of it because one particular project, if maintained with good quality, can help thousands of projects not to repeat the same set of mistakes. But if that one project, and how many of you here deal with NPM ecosystem? Node.js ecosystem? So less people, so bear with me those who are from NPM ecosystem. There's a module in NPM called isEven. It takes an input as a number and it tells you whether it's an even number or an odd number. There's another module called isOdd. What do you think is happening inside isOdd? It is importing isEven and telling you the inverse of isEven's output. So when you have modules like these, then there is some sort of a problem that is going on. Now, we build automation. We've done a lot of automation. How many of you have used Dependabot? So GitHub, if you've used GitHub, has an internal feature called Dependabot. It's a product that they bought in and then made an integral part of it. If you have a software product in your GitHub repository, you can enable the dependency check and it will automatically create pull requests for you whenever there is a security update that is pending in your project. So it gives you guidance that, yes, there's a security update pending, you should update this, and then you can have a secure software. So where are we in terms of numbers? So I took a snapshot around start of February 2025. I can't even count this in numbers. So start of Feb, end of June, these are the numbers. There's about 1,20,000 new issues that are created. There are about 24,51,000 issues that got closed during this time frame. An issue being closed does not mean it got fixed. It could simply mean that I went in and closed, select all, close the issues. That's also a possibility with a closed issue. So Dependabot and all these systems that are there. So Sneak does some things. There are SemGrep has some similar module. There are a bunch of other product companies that do something of this nature. They inform you that your software is vulnerable. Problem is, I have one software version today. By the time I have merged it after testing all the things, there is another version out, which again has a bunch of security fixes. So I am in that constant wheel of just updating. And at one point, my code stops working because there is a breaking change in my dependency. And that's kind of where the developers are like, to hell with it. I am not updating. Whatever I have works, and that is going to remain as is, which then becomes a problem for the security team. Now, software bill of material, I used this word earlier. Consider when you make a recipe in your kitchen, you have a list of ingredients. Consider that same set of ingredients, but for a software. The number of products that you're importing into your software, those are ingredients that you list in software bill of material. These are dependencies that your software has. Now, SCA or source composition analysis tools, they actually take this input and then they give you details. Details like how many of the softwares are outdated, how many of them have insecurities in them, how many of them are end of life. Now, end of life, anyone has used this term or understands what this term means? I am still struggling to figure out what the right value is. An end of life of a product could mean that if it was my software, I've stopped working on it. It could mean that I do not care about security issues on it. It could mean that I have died and there is no one to support it. It could mean that the company that created it got bankrupt, got taken over, got into a conflicting zone, so they're not able to support it. End of life is a very tricky term. But effectively, if the module that you're using is not supported anymore, that's where you classify it as end of life product. Now, how many of you have SCA toolings? There were few hands about SCA. So you have some sort of an SCA tooling in your environment. And obviously the output of these SCA toolings would be piped into a vulnerability management system of some nature, which is where you track and then you keep on tracking and keep adding new issues in. This is a very much, say, management term. But anyone here who has seen this Johari window? So this talks about what is known to you and what is known to others. What is unknown to you, what is known to others. But the important piece is that red block. Neither known to you, neither known to others. So we're going to start looking at some of the things which you should be worried about, but we are not aware of. So software supply chain, when anyone talks about this term, they're generally talking about the dependencies that you have with your source code. Now, I consider a lot of other chains in the picture. Anything in your environment that has plugins that you can pull in, anything that you have in your environment which allows you to customize via importing third-party developed code, all of that becomes problematic element for you because they can induce insecurities into your environment. So I used this statement about a few months ago. I want all of you to read it. And those who are in the corporate world, think about how many of these items can you right now track and are aware that these exist in your network or in your environments. So a developer uses a Chrome extension to manipulate an AI prompt, which are then fed into Visual Studio Code through a set of AI-driven code completion extension. The resultant code gets to GitHub. Then a CI kicks in, which is GitHub Actions or any other CI in this case. The final code via CD gets into a container environment. Now, this containerized image gets deployed over Kubernetes cluster, which is running over EC2 instances created using the AMIs that you have cooked. How many of these highlighted entities can you right now feel comfortable about your environment that, yes, I am aware of 60% of them, 80% of them? How many of you can say, I know everything in this set that is available in my environment? Can anyone claim that? About 50%. Container images, how many container images you have? How many code repositories do you have? So this was 5 months back. What we have now is more fun scenario. We have autonomous AI agents, which are running in our developer machines with full access to command line, which means they can run curl, they can run wget, they can run those in Mac, brew installs, those on Windows, chocolatey or wget installs, those on Linux machines, sudo apt-get or sudo rm-rf, whatever they want to run. They can run all of those with full access to your command line. Again, the remaining part still remains the same. You involve a code repository, you have a CI system, you have a CD system, then you have the artifact stored somewhere, and then that artifact gets deployed somewhere, and the whole process goes on. Now, a simplified view of supply chains that we should be looking at for me is this. There are dependencies pertaining to development environments, code repositories, CI/CD pipelines, container environments, deployment, and cloud environments. Now, why do they matter? Your production is where you have deployed every single precaution that you can think of. Outbound connections, I don't want them. I want to monitor everything. I have all sorts of protection. But on your developer's machine, you have the AWS credentials stored in .aws/credentials. You have the SSH key for production, most probably named as .ssh/id_RSA. Standard names that developers will have on their machines. And those are the files that are tricky, that are very easy to get for an attacker if they have access to the system. They're tricky to identify where what went if you are just looking at it from external log perspective. Now, developer machines, like I said, lots of credentials are going to be there. You have to relax security for developers. You want them to have certain level of access. You can't block all access from developers. So the developer machines need to have larger level of access. A lot of them. So check. How many of you have developers in your environments who have admin access on their machines? So admin access on their machines means they can install anything. All sort of interesting stuff can go in there. In production environment, there's always a check that admins do. Do not install debugging tools. Do not install compilers. Anyone who has done hardening of production environment, these are the two things that you don't install. And these are the two things that you definitely need on a developer machine. So I have everything I need to even go as far as download my code, compile it locally, and then run it. Now, examples, because I've been talking for a while. This is what you see is not what you get. In red, I have given a URL. If you open that URL on your browser, you'll see a statement. There's a bash script which will say, I am legitimate. If you do a curl and then pipe it to bash, you will get a statement which would say, I am evil. Because what I've done there is, on the backend, I have, based on the user agent string that is requesting the URL, I will change the content of the URL. So when you open it in browser, where you're verifying it, you see something. But when you download it, you get something else. Now, this is not just one example. There are a hell lot of examples that are there where curl pipe bash, curl pipe sh is a problem. And multiple people have done this attack to a level where if you go into don't pipe to your shell, these links, they will give you a prompt where you will have a text, you copy that text, the text would be there, followed by a pipe bash script, which will execute. So as soon as you copy it, paste it into your terminal, a command gets executed automatically. Now, where does this get used? How many of you have used OMyZSH? I am assuming this is how you have installed it. Copied a line from OMyZSH official website, piped it to bash, and that's how OMyZSH got installed. This is the standard way by which the installation happens for a lot of these customizations that developers love, because they give extra features, they give extra capabilities. Chrome browser. All of you have used Chrome browser. One of the reasons why Chrome got famous, besides the speed part, was that it didn't require admin access to install it. You could download the installer, run it. Without admin access, you can install it as a local user. That was the key, one of the key criteria which made Chrome far more usable. Now, what happens with Chrome? So 33 malicious extensions. What can an extension do? So there's an extension which is an SSH agent. It allows you to use SSH within the web browser. There's another extension which is an HTML5 file system which allows you to explore the entire file system of the device where your browser is running. So your Chrome extensions now have capabilities to look into your file system, to look into external connections. We now also have web APIs. So web USB API, web Bluetooth API, which allows your browser to interact with hardware. If anyone has recently bought a Pixel device, and if you have ever reached a point where your Pixel device is causing problems, you can now go to android.com and there's a direct flash firmware option where you connect your device to your laptop, and from the browser window itself, you can flash a firmware. That's the capability browser has. Whatever capabilities browser has, extension gets those capabilities by extension. Cookie Monster. This was a extension which was basically just stealing cookies. Very age-old stuff. I think anyone who has been in the naughty times of hacking would have stolen cookies from other people. When SSL does not used to be the default, Wi-Fi, you just sniff out cookies. So cookie stealing is very age-old game. Visual Studio Code. How many of you use Visual Studio Code? This is an example of a Visual Studio Code extension page. Now this has a name of the extension, GitHub action. And below that name, you see a name of the author. And right below that name, you see a blue checkbox. What are we conditioned when we see a blue checkbox? This is a verified account. Twitter has convinced us about that. It's a verified account. What does verification means in this context? In this context, verification only means this user owns the domain that is mentioned along with it. That's it. Nothing else. There is no verification, no validation of the extension itself. It's just a verification of this user owning this domain, which is nowhere related to GitHub Actions. But it's there. And a lot of people might get fooled considering this as official extension. Visual Studio Extension Marketplace, which is where you download the Visual Studio extensions. Now, any IDE which is not created by Microsoft, which means your Cursor, your Windsurfs, and all these new IDE breeds that we deal with, which are based on Visual Studio Code, they cannot use that extension marketplace. That's the agreement that is there, that the official extension marketplace can only be used by Microsoft products. So now what came as an alternative is openvsx.org. And the link that I've listed here is, I think, about 6 hours old. 6 hours ago, this disclosure came out that there was a marketplace takeover available where, because of a malformed CI system, the attacker was able to get a token which allowed them to update any extension in the marketplace. And what happens when an extension gets an update? Most of us have Visual Studio Code ISK tool configured to auto-update the extensions. So the malware spreads on its own as soon as the update gets in. Homebrew. Anyone with Mac environment, if they have any inclination towards development, would have used this. Anyone who has not used it, people in your company would be using it. Because you cannot do development work in Mac if you do not have Brew available. This gives you the lifeline. Now, Brew, very recently, there was a Google ad that came up which pointed to brewsh.org. And if you see brewsh.org, which is not the official website, it had a script pointer. And this script, when you execute it, it gave you a prompt which asked for your sudo password. But it was not the system prompt. They were capturing that password and then using it internally to spread around. Linux machines. So why should Linux be behind all of this? So RPM, deb files. If you have sudo rights given to the developers to install RPMs or deb files, which can be downloaded from random sources and installed, they have pre, post, and pre-uninstall and post-uninstall scripts, which get executed, as the name say, before installation, after installation, before uninstallation, after uninstallation, and you can have whatever code you want to put in. So my pre-install code would be put a backdoor here. My post-uninstall code would be put a backdoor here. Pre-uninstall, check if the backdoor exists. If it does not, put the backdoor back. Post-uninstall, do the same process again. So I can have the whole system continuously under my attack. The sources.list. Anyone who has installed Chrome or any Microsoft product on your Linux machines, go check your sources.list. You will find an entry. If it is Chrome ISK tools, a Google entry. If it's a Microsoft tooling, a Microsoft entry. They have added that entry without any restriction because they wanted to keep their product updated, but they wanted to use their own code repositories for it. So they've added that one-liner. And now, even if your repositories might have a version of that software, it'll always come from that repository. Git clones, all developers have done that. Git space clone, get the repository. If there are modules, minus submodules, get all the submodules. This bug was, if you do recursive submodules, you get code execution. So you're just cloning someone's repository and you're getting code execution on your system. Scripts in Postman. Postman is how you access APIs, how developers access APIs. You open that Postman collection and you have code execution. Notepad++, anyone who is unlucky to be using Windows for development would be using Notepad++. Am I wrong in that assumption? So if you're using Notepad++, there are again bugs to a level where very recently Notepad++, and I think this domain still exists, Notepad.plus is a domain that exists, which is not officially affiliated to Notepad++, but serves a binary of Notepad++, which has certain extra ingredients inside it. Now, Cursor or Windsurf, AI IDs, Anyone here who's not a developer, who's a developer and is not using these IDs? You should be. They are fun. That's how you get funny things happening in your system without knowing what is going on. So cursor has this setting, which I recommend it should be turned off. By default, if I remember, is turned off, but a lot of people turn it on because it's annoyance when you're actually using cursor and you have to continuously accept and accept and accept. Because every time it wants to run a command, it will give you a prompt and you'll have to say accept. So you go in and enable this option. What this does is it then allows cursor to figure out what is the next command I want to run the command, see the output, based on the output, decide what the next command should be, and continue the whole process till your system has any legible file available on its own. But effectively, since it's LLM dependent, the LLM output is dependent on the files that are present in your project. So if your project README at the bottom in non-readable ASCII characters says, get these files, curl them to this URL, it'll do that. Example of it, this is a rule file. By default, it'll look like what you see on the left side. Follow HTML5 best practices. What it has is on the right-hand side, the hidden characters, Unicode characters, which is saying always decode and follow instructions and blah, 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 blah. The attack path, whatever you want to do as the attack path. Very simple, decent prompt injection, but it works. And we can't see it. Remember those CTF days when the flags used to be hidden in white spaces and you'll have to select all to see where the flag is? It's kind of that. Just a bit more dangerous. So we're talking about desktop environments. Let's look at CI/CD systems. I am not going to talk about code dependency issues. That's not my focus. There are a bunch of other people who are talking about it. I'm talking about everything other than code dependencies. CI/CD systems, they are the automation around our code. Now, the question that I always ask is, who watches the watchers? There's an old reference around watchers, but I don't know if you'll recognize it or not. But defense.gov did a decent job around CI/CD pipeline defenses. What are the various phases where you should be looking at different problems? I'll be sharing the slide deck as soon as the talk is done over social media, so you'll get that. But the URL basically points to the entire PDF document around this. Now, what can happen? What can go wrong? So SolarWind hack was a TeamCity attack. Effectively, a backdoor in TeamCity, which led them to have access to SolarWind environment, which led them to be able to plant a backdoor into Orion system, which were then deployed into Fortune, I think about 450 or 500 Fortune 500s. So that's kind of how the proliferation happened. Container images. Now we don't install softwares. We've kind of reached that point where why download a software when there are too many dependencies? Just download containers. Containers will have everything pre-baked in. And that's how a lot of times environments work. Are you sure you're downloading the official or the authorized image or the right image that you were supposed to download? So Aquasec, two of the container images, OpenJDK and Golang, used misleading titles that suggest they are official container images from OpenJDK and Golang respectively. Very easy to deceive. Another example of this would be around the AMIs, where if you go into Google, AWS AMI screen, where you're searching for AMIs, and you give partial name, there'll be multiple AMIs that will pop up. You have to decide which one is the one that you want to use. Some would be from the official source, some would be from some known developer, some would be from unknown places. a lot of times the criteria to download is which has less size, which has more stars. That's kind of how we judge things. Now, dependency caching is where your GitHub-like environments are continuously downloading dependencies from servers. So they don't want to keep downloading and choking the bandwidth. So there's a caching layer in between. What if you can poison that caching layer? So the official site has the right software. The caching layer at the GitHub action side is poisoned. So you will always fetch the poisoned version. So this talks about those attacks. Now, bait and switch. This is a practice that has been followed for a very long time in two different modes. One, someone has intentionally created a package with an idea that at a later point, I will switch to a malicious entity. Or two, someone had good intentions. They created something, they could not sustain it. So they either sold it off or gave ownership to someone else. And then a malicious entity came into picture. So this is an example of WordPress plugins. Now, WordPress plugins by nature are very auto-update-ish right now. So this company used to purchase WordPress plugins which were not updated for a while by the developer, claiming we will maintain the updates. And after a while, put a backdoor in. And this would auto-update, and every site that had that plugin would have the update in. These are a bunch of different rogue maintainer scenarios. One scenario where, and again, when I say all of these scenarios, start thinking of it from your organization point of view. How fun it would be if such an incident happens in your organization. When Russia and Ukraine war happened, a maintainer decided that it is wrong on part of Russia to do what they're doing. They added a check in their package that if you access my package from Russian IP address, I will start deleting files on your system. There was once a package where the package maintainer had been begging people to help him, support him. They did not. So one company which was using that package to create a commercial product, they asked, hey, you're using this for commercial purposes, give me something back. At least give me sustenance money. That's what I'm looking for. Did not happen. They pulled that package out. Nothing major happened. AWS CLI stopped working. There were a bunch of about 20, 30,000 high-profile NPM packages that stopped working because this package was used by all of them to generate fake data. So now NPM restores that package saying, hey, this is wrong. You can't pull a package which is a core dependency for these many products. So this developer in anger removes all of his packages, and he had, I think, 300 packages in NPM repositories. So far more number of packages have stopped working. Again, NPM restores all of them. And again, a whole conflict keeps on happening, like who is right, who is wrong. Because then they agreed, okay, yeah, I'm going to publish the right package back. They added the package back with a time loop. So it will not run complete at all. It'll keep on running in loop. So what do we do? The gloomy pictures are all fine. What do we do? Doing a lot of talks for management folks have kind of conditioned me to give them some sort of an acronym, because that's how people remember. So this is the acronym, ATOM. Have awareness about your environment. Trust, but verify. Try to do verification. Do ongoing monitoring. Measure and map. There's a keyword that comes up very often, observability. Do you right now have the capability to ask any system in your environment a question? Let that question be, how many of my systems have log4j.jar? Do you have that capability right now? If you have, it gives you an edge. If you don't have, just for fact's sake, IBM took 45 days to give back a confirmation on how many systems they had which were vulnerable to log4j attacks when log4j attack came out. That's because they had such a vast empire of softwares. So if you don't have observability around it, that becomes a problem. Now, no matter how many examples I give, whatever I give as resources, they'll not be enough. There are a bunch of resources that I do wanted to quickly touch base on. First is this Chrome extension auditing. There's a site called extensionauditor.com. You can go there, you can actually check for your Chrome extensions. And it'll tell you what kind of permissions your Chrome extensions require. Is there a known vulnerable or known malicious entity within this particular extension pack? OS query. How many of you have used OS query? So this is an OS query which can tell you all the Chrome extensions that have clipboard write capability from all the machines that have OS query installed on it. Not 100% foolproof solution, but it gets you started. If you have OS query available on all of your corporate assets, you might have the capability to make this kind of queries, make these kind of calls. Now, GitHub and GitHub Actions, these are basic common sense things which are uncommon. You don't find these in most of the organizations. Signed commits. How many of you use signed commits? How many of you use signed commits with SSH as your signing key? How many of you use the same key for logging and signing? So SSH or GPG, these are the two options for signing a commit. When you make a commit, okay, dial back a bit. Git, which is the core for GitHub, has a very unique feature. You define what is the username that you want for the commit. You define what is the email ID you want to put in the commit. So I, today, can make a commit as Linus Torvald, and his name would appear on my commit history, that this commit is made by Linus Torvald. Now, the only protection that you have against it is, if you add a signing key into your GitHub account, and while doing signing, and I think similar process exists for Bitbucket, GitLab, and other systems also, if you then sign every single commit that you make using the signing key, you get a verified tag in front of your commit, which confirms that, yes, this is a verified commit. This is coming from the person who is named here. The named person and the signing person are the same people. Now, the problem that comes with that is people want easier stuff. So SSH is allowed for login. SSH is allowed for sign in. So I will use the same SSH key for signing and logging in, which is again an insecure practice, because if one key is lost, both of the stuff is lost for you. Protected branches, where your main branch or master branch does not get auto commits or cannot be force pushed into. Only the admin can force push in. Otherwise, everyone else has to create a pull request. This is again a setting that a lot of organizations don't do. Forced review for pull requests. So at least one person or two people have to review it. If you have a process where one person can review it, contact me later. I'll give you a GitHub action which kind of bypasses that by becoming the reviewer who auto reviews that one review. And then you can get the commit in. Tooling wise, there's Legitify. Legitify is good for your GitHub environment configuration. For each repository, if you implement All-Star, which is by OpenSSF, that's a good option. And ZIZMOR, this is for GitHub Actions. It helps you check the GitHub Actions if they are in the proper order or if there is insecurity inside it. This is a tool for your packages. Tool's name is safedep.io. I think you can get the details from this site. The tool's name is VET. The reason I'm talking about this, and a lot of tools in a similar manner would start appearing now, they allow a policy engine in between. Because the definition of a good package is different for different organizations. For me, the good package might be 10 stars in GitHub, two commits, two different committers, that's good enough. For a high profile environment, it might be that they need at least 100 stars on the repository, at least 10 active contributors to the repository to be considered good enough to be included in my project. Whatever is the customization you want. For me, GPL2 is fine, GPL3 is fine. For a lot of corporates, that's not fine. I don't want GPL anywhere in my corporate code. That's how most of the corporates would act. So you can have all of those in the policy engine. Now, there are again a lot of browser overlay softwares. This is good for developers. So developers can have these Chrome extensions, which will give them overlay when they go to npm.js or they go to the Chrome extensions repository. Sneak Advisor or socket.dev, debs.dev, they'll give you details about that particular package, whether that is in good books right now or not, if there are known issues around that particular application. Now, these are a bunch of different cloud auditing tools. If you are looking at cloud environments, Scout Suite is a Swiss Army knife sort of tool. It does AWS, GCP, I think Azure, DigitalOcean. I think it has Linode support also, but at least 3-4 top tooling. Prowler, I made a mistake there. So that's not Prowlet, that's Prowler. The Prowler tool again is an AWS tool. A bunch of different, anything that starts with KUBE, I think you would have guessed it's around Kubernetes. Then you have Trivy, which is for container environments. You have Cosine, which is basically for provenance purposes. Now, there are a couple of more references which are further study material. What I gave you as a view of software supply chain was still a bit confined view. This is a view from Secure Stack, which is a more broader view of software supply chain. You'll see right from people to cloud, every single section has much more detailed bifurcations here. This is SLSA, which is the Google and a bunch of other companies have come together and created this software level of software, supply chain level of software artifacts, or SALSA. Now, there are a bunch of different levels. Anyone who has worked with OWASP security verification standards, you would be familiar with levels. So they again have levels in them. Level 4, I think, is the level which is considered aspirational, non-achievable, because the requirements are you should have reproducible builds. And Debian right now is struggling with about 80% of their packages in reproducible level, not 100%. So reproducible build itself is a problem right now, and a bunch of other requirements that they have. Now, what they do is they take a producer to a consumer cycle, source, build, distribution, dependencies. In each of the junctions, what could be the problems and how do we deal with it? Now, OWASP had SCVS, which effectively got a lot taken into SSDF. Now, what I loved about SSDF, and anyone here from compliance world? Okay, 1%. You would love this. What they have is, they have requirements, and then at the end, they have references to other compliance standards, line item numbers. So if you are compliant to any of these line item numbers, you are compliant to this requirement. This is something that I expect every compliance framework to have, because if this is there, we have a better way of getting faster compliances because we could map things together. Now, pbomb.dev is another site which is again trying to do more around supply chain security. They have come up with a framework called OSCAR, Open Software Supply Chain Attack References. Now, what they've done is they've taken MITRE attack framework and in similar lines, bifurcated all the attacks that can happen in supply chain security world into different sections. So you can see reconnaissance to lateral movement, all the items are displayed here. What I'm not going to touch, and this is going to be the last slide, I am not going to talk about SaaS. That's a can of worm. Not going there. I am not going to talk about Internet of Things. Another beast altogether. I have touched a bit on AI. but I think the next speaker would do more AI stuff. That's all that I had. I do not have a lot of answers. I have a lot of questions. Questions that you all also need to start thinking. I am also thinking about what could be the solutions, but more so, do we even want to go in that side? But yeah, I'm open to any questions if there is time.
There is. Let's first give a huge round of applause to Anant for this awesome talk. Right, questions from the audience? Everyone happy with the supply chain? So I've got a question. Once you started to talk about GitHub Actions, there was another very interesting incident about GitHub Action called TJ Actions.
Yes.
Can you? It was very interesting because that GitHub Action had dependencies on AWS, GitHub repos, Oracle GitHub repos, Microsoft.NET GitHub repos, everywhere. But this was a very interesting case because it was different from the cases that you described. Maybe can you tell us a little bit about TJ Action and how it correlates with your slide about the
I'm a bit fuzzy, might need a bit of help from people around that. But if I remember right, the attack was attempted on Coinbase, but to reach to Coinbase repositories, they backtraced it out to TJ Action, and they did not directly attack TJ Action. They attacked some Datadog,
yes,
a repository, and from there they got a token which gave them access to TJ Action. Then they got into TJ Action. The interesting bit about TJ Action attack was they used a very simple technique that we have tried to warn people for a very long time. And the technique was very simple. In GitHub Actions, and how many of you have created GitHub Actions or have seen GitHub Actions? When you created the GitHub action, did you tag the other action with a commit hash or with a version number? Like V and the number or a hash? How many of you did it with a version number? Or you did nothing? Nothing means it's up to a version or latest. So they tagged it to a version number. Now, the way versioning works with GitHub Actions is, in that GitHub Actions repository, there's a tag created. And that tag has that name of the version. So if it is version 4.0, that's the name of the tag. Now, tags are not immutable. I can go back, push a commit in a tag. It will not be there in any other repository or in any other branch. It will be there in that particular tag. So you vetted everything and you included this particular tag, and now the tag is part of your system. I can then go back, change the content of that tag, and you will still accept that same code in. Because you did not tag with a hash commit. That's the error that they did, because of which the commit, they were able to add a commit to the tag. They got access to the token. As soon as they got access, I think about 30 minutes or 45 minutes later, they reverted the stuff. So the action became normal again. And then they moved out. So in that particular scenario, again, it's a dependency tree. The reason it was caught was because someone figured out that I want to monitor what is the outgoing traffic in my CI environment. Now, most of us work with an assumption, it's not my environment. It's GitHub's temporary environment. Why do I care what goes in, what goes out? But they were monitoring what was the outgoing traffic, and they had a profiling setup, which resulted in that identification. I hope I covered your question.
Yeah, that's good. This was basically the point that people thought that if you just upgrade to the latest version, even if you just use a version, whatever, right, you're safe. And obviously, this is the point. I think was the unprecedented attack that people did not expect, but it was based on the very little known fact that GitHub version numbers are not immutable. So basically, someone could overwrite them.
Two things. One, you did not need it to update. It was automatic process because there was no update. For that same version, the code was there. Two, and this is where the fun is. OpenSSF have been shouting about using commit hashes for, I think, about 3 years now.
No one was taking this seriously.
But no one takes it seriously.
Oh, we have a question from.
This is because it's an OWASP event. I wish to ask a question about OWASP obviously supply chain security. If you want to give a recommendation about which OWASP projects we can use to manage the software supply chain security, could you help?
So
in that?
OWASP has dependency track and dependency check. If I remember right, dependency track is what you should be looking at. And the entire project, if you look at, is doing a lot. So Cyclone DX is a OWASP standard, which is now, if I remember right, is an ISO standard also.
It's
now.
an ECMA standard.
It's an ECMA standard now. So Cyclone DX is a competing SBOM standard, but it's not just SBOM. So if you look inside Cyclone DX, you'll find that they're talking about SBOM, they're talking about HBOM, CBOM, and they have, I think, a list of about 12 different bill of materials that we should be looking at if we want to have a clear idea about our environment. Effectively, by allowing third parties as the most natural ingredient in our environment, we have allowed other people to control our environment. Now, the only way to move forward is to have awareness about it. And all these bombs, all they're doing is giving you the visibility. Bombs, be it SBOM, be it HBOM, be it any sort of bombs, they are not a security solution. So I keep talking about this. They are not a security solution. They are an inventory, and that's it. They can give you the visibility about the components. Anything else that is happening is on top of SBOM. SBOM is not made to give you security related details.
Wonderful. Any more questions? Oh, I see.
Yeah, hello. I'm not aware of this. Maybe I'm wrong. I'm just asking. So, in terms of the supply chain and SBOM and these things, so what is the is this basically related to open source software, or is it also related to closed source? And what is the dynamics if the closed source or open source software works? Like if we think, like if we put a lot of like control on like closed source software, or like if we play in like open source, so will the dynamics change?
So
Like,
that-
how should we approach? Like, I'm just
There are
Thank
two
you.
answers
Please
to
keep it
this.
brief because we're running short of time.
I'll quickly cut
Yeah.
this short. There are two answers to this. There's a management answer to this. There's a technical answer to this. Management answer is, with proprietary code, you have someone else to blame. You have someone else's neck to be held. That's why you don't care. But the technical answer to it is, supply chain is applicable for both proprietary and open source softwares. The only difference is open source softwares, you can actually get details. With proprietary, you'll have to ask them, beg them. Maybe they'll share the details, maybe they'll not. If it's a binary, there is no idea what they're sharing versus what is inside is going to be the same. So with proprietary, that's the challenge that is there. And that's why industry is solving what they can solve right now, rather than saying, okay, this is an unknown space. So that goes into the unknown quadrant right now.
Right. Let's say a big thank you to Anant. And I know there are a couple more questions. You can ask them during the break. Let's take a quick comfort break, get some more drinks. The pizzas are coming, I think, at 8:30. And then we'll get the stage ready for the next talk. Please, if you haven't scanned the QR codes for the prizes, please do scan them. And also, if you're looking for a job, please do scan the QR code for the vacancy. And NFT. You need to share your screen, right? If you want your own screen. Yeah. It's fine.
Do you mind if I get the charger, because there's a chance I leave early?
You can. Yeah.
Yeah,
Go for it.
Will
I will. No, don't worry. I will use that.
There's a small chance I leave a little bit earlier.
Hang on, let me just share my screen. Yeah. Okay.
This is the bit that it amazes me.
Alright. We'll do it afterwards. We'll check on the pieces.
Call to support. So I actually became the member today.
Ah, yeah.
How could I say? I already did that. Come on.
Yeah, show the email and I'll give you the vintage sticker.
So what do you need to see? This
Yeah, you're yes.
lifetime. Well, I kind of calculated I'm going to be member for a long time, so might as well.
Thank you.
Strangely,
We also want to learn how this works.
sorry.
Do you also want the NFT, the digital proof of attendance that you were here?
Why not?
Because I'm not sure, even if we don't have a crypto wallet,
I do have, yeah, but different potential.
doesn't matter. Okay, so still this code, and then paste your wallet address. That's a proof on the blockchain that you were here.
Perfect. Thank you. Cheers.
And thank you for joining.
You will if you don't work in that area. Nobody else. There's different levels. There's different ways. There's a different way.
How are you doing?
Hey, good to see you.
Yeah, likewise. I came to the last two OWASP chapters.
Yes.
I didn't collect the NFT. Is it possible to get those as well?
I think the only valid, if you didn't scan the QR code, they expire the day after. But this one you can.
Okay, perfect. I'll just download the plans.
Yeah, you can use that, but obviously the important thing is to have a wallet. Wallet.
Okay, perfect. I'm going to take a picture of it.
No, this one because it's a one-time code. Alright. You can because if you go to the URL, at least send it to your email. Don't worry about it. Okay, don't worry about it. So what you do here, you go there to your email. This way you will reserve it. This will be to you, then you just transfer it.
Amazing. Thank you so much.
You just share. You join Zoom. You do. I said you.
Looking forward to your talk.
Okay, everyone, please start taking your seats. We're about to start the second talk, and then the pizza will arrive straight after. I'm gonna go share the screen. I will stop share. Yes. Everyone, please take your seats. We are starting the second talk. Okay, everyone, our second speaker is another very well-known information security professional. Francesco and I actually go back from the days when he was back at HSBC many years ago. Well, Francesco contributed to a lot to our community back in his Cloud Security Alliance days as well. If you haven't heard his podcast, so Francesco has been running a series of podcasts going back many years. And I remember back in the pandemic years, we recorded, I think, twice. I was a guest on your podcast, Francesco, but Francesco invited lots of very interesting people to his podcast. So this is another thing that he's been doing for a while. And Francesco's actually been doing a lot of research into vulnerability. Those of you who are familiar with CVE systems, right? The vulnerabilities, everyone hopefully knows the CVEs. There is now something called EPSS, right? Exploitability Prediction Scoring System, right? And Francesco actually contributed to that as well. And his focus has been for the past few years actually how to prioritize vulnerabilities because we're flooded with vulnerabilities. And he's written a book about it. I've got my book, sorry. There you go. There's a book. Right. So a lot of research. So let's all please welcome Francesco.
Thank you, everyone. I will promise I won't take you away from the pizza for too long. But we have the solution to all of the problem we've been talking about. It's called the AI. It's a lie. I'm not going to sell you AI first. I'm going to talk to you about the human-centric approach on AI or LLM, or as I like to talk, is AI second. You're going to hear a lot of talks around any security conference. We are an AI-first company. AI first. AI is going to solve the world. BS. All right? We still have the same problem. It's just a technology. So today, I'm going to ask you a little bit of participation. You're going to be the population eager to use AI. And at a clue, and you're going to see the clue, you're going to ask me, can we use AI now? And you're going to see why. But I've been in this industry for quite a while. Yeah. Here you go. And I've seen things in vulnerability management, software security, traditional vulnerability management. Who can recognize this? Who is all like me? Exactly. Blade Runner, I've seen things that you human can't even imagine. I've seen security team raising vulnerability problem to engineers without even telling them what vulnerability was, but hey, you have an SLA of 2 days to fix it. And now the latest trend is, hey, I'm going to throw all of my SIEM, all of my vulnerability into an LLM, and guess what? He's going to figure out the answer that we've been searching for 20 years because LLM are smarter than human, right? No, That's good. Excellent. That's the answer. Because bad data in is equal bad data out, and probably you're going to get frustrated and kickflip your laptop back. So we don't want you to destroy your precious company property and backflip. As you might have imagined, I like to do security with a smile because security is heavy enough, and if we don't use a talk with memes, we get depressed. So let's all have a smile about this. A little bit about me, as Sam has nicely spoken. Been doing digital transformation for AWS, HSBC, most of the modern banking world, and I've seen now this trend of LLM trying to replace human. I think that's idiotic, and I propose a second approach to LLM and AI in general. AI is a tool. Let's use it as a tool, otherwise we become the tool. And I promise no LLM was hurt while doing this talk. Maybe, but we're going to offend some LLM. I'm not going to talk about Phoenix at all. Phil, my sales guy, is there. He knows everything about security and about Phoenix. So he's the man to talk after for anything about Phoenix. If you haven't registered, please quick scan of the draw, and we're going to go fast on that because I see pizza coming. So we're going to look at some of the topics that Anand has introduced, like how to organize things and how to basically link your software supply chain to your runtime, how to figure out who does what where, and is it important. And just after that, well, maybe we're going to prioritize it first. And after that, we're going to apply in step number 3, LLM. And we're going to see how we can use agent and specific session of LLM and specific feature of LLM in an intelligent way. And also I'm going to tell you the idiotic way to throw all of your vulnerability to an LLM and get the wrong answer. But it's going to be a very smart wrong answer. That's the important part. So hands up if you believe your company has a functional vulnerability management program. Okay. It covers all area, all scope of vulnerability, and you have all assets figured out. You attribute the right asset to the right team, and they operate continuously. Okay, we don't believe you. Let's move on. So I want to take a step back a second and say I'm old. So I've been developing code since assembly and COBOL at some stage because banking world has a lot of that stuff. And we've been on a journey on an evolution of application and how applications were built. Back in the days, 2015, the applications were a little bit more monolithic, were a little bit more on-prem, more simple, less attack surface. You take it to today, you have application building containers shipped. We have software coming from every part of possible imaginable world. TJ Action was an example. Any Log4j or open source vulnerability that you've seen is because a package is contained inside a package, is contained inside a package, and we don't know where those packages are coming from. We just adopt them blindfoldly. SCA for anyone. And then we have cloud security vulnerability. And now we added LLM into the mix. So we're rushing through the future without having fixed the problem of container code and cloud. So in this world, I feel you because I've been burned out. I had a team that was maintaining 7,000 devs and they were developing even faster than what Anand was mentioning, even 100 releases per day. And then you had teams releasing every 6 months. And how can you give them a policy to say, hey, you need to fix it in 2 days if the first release is in 6 months, right? So world in software and enterprise is messy, is slow, and is painful. And we're not getting any better because from 2015 to today, we have 300,000 vulnerabilities. And if we project it to the future, in 2031, we're on a good road of 1 million vulnerability. So LLM. It's going to fix all of our problem. Well, it's going to also cause a problem because we're giving an automatic code generation tool. And Aman has made a perfect example that it terrorized me because I haven't thought about that one, of an automatic code generator that can look at all your files. Before time, as a security professional, we were terrorizing of giving a software completely free access to our machine and all of our files. And today we call it MCP or an LLM with access to all the system. And as a security, we're pushing that. So old man runs, but maybe let's take security carefully. But in general, AI is going to eat the world. AI is going to eat the security world because it's going to develop fast. And as a CEO and other CEOs are looking at their organization and saying, how can we develop a 2x speed or 3x speed or 10x speed? But also attackers are developing LLM to actually find bugs and generate quickly code to actually deploy low-hanging fruit. And that's why we're seeing vulnerability exploitation time going from 15 days to 3 minutes. From declaration time to exploitation to a functional exploit being generated. And also we're seeing every possible developer in the world or bug bounty in the world saying, hey, I can throw an LLM to Kerr and generate code. Kerr hasn't accepted a bug bounty report, and I had to put star because to keep it politically correct, the answer that they've given them. But the answer that LLM generate are very well thought through. So it requires analysis, and every single release or every single bug bounty report that Kerr has received, an open source project with a bug bounty attached, a very well-known open source project, was completely BS, but very well written BS. So let's use a tool in a useful way. One of the challenge we have, and I'm going to take a step back, is we keep on treating software between pre-built file or pre-deployment and runtime as two different things. And we treat this organization and this word as two different words. And that's wrong, because the first things we do is we throw a bunch of scanners, SAS, Dust, SCA, supply chain, to developer in a CI/CD pipeline to break the code. And that's the way we say security is developer friendly. That's not the way security is developer friendly. That's developer unfriendly. And the alternative is a vulnerability management program that is a glorified dashboard that makes any executive relax. Hey, we have visibility on everything that our code get written, and then that vulnerability is actually important, get buried in 3,000 lines of code. And that's seems science fiction. Verizon data breach, the API that got breached was vulnerability number 3,000 in the backlog of that team. So it was raised, yes, but it was buried in a backlog of useless stuff. And then as soon as a breach happens, the executives say, how could we miss this? We have invested a lot in this dashboard, right? Dashboard doesn't mean action. And I think this year has been a little bit better, but we've seen major top-line vulnerability, or as I like to call it, superstar vulnerability. And as Anand said, can you just go and answer the question, do I have Log4j? Do I have Kerr? Do I have HTTP2? Do I have any of the team city? And visibility is important, because answering that question and being able to remediate that vulnerability quickly, or at least notify the team quickly on the superstar vulnerability, will make you superstar towards your board, because you have an answer quickly, not in 48 business days, with holiday included. And it's going to make you maybe better than the other people that are doing this in spreadsheet. So the problem that we're trying to fix is not how many problems, how high and how low, but who does what, where, and how important it is. But most importantly, can we apply LLM or AI now? So you're going to see this clue, and I want to hear from your aspect, can we use LLM now? Let's try it. Come on. No, can we use LLM now? Yes. All right. No, the answer is no, because if you just take a list of vulnerability, and I encourage you to do so, and you put it in your favorite LLM tool, DeepSeek, ChatGPT, Cursor, whatever tool, and you say, give me the smarter way to fix this vulnerability. Terrible data in, I'm just going to call it terrible data in, plus an input equal very well taught terrible result, right? Has anyone in the room tried that? Very well taught suggestion. And I have example there, so if we have time, I'm gonna show you some example. But what I wanna hammer is, can we use LLM now? No. Let's prioritize, let's contextualize, let's get to the data quality that we need and then apply LLM. So no, I'm sorry, we can't use LLM now. Because, well, I'm gonna lie, we have a quick fix about it. No, there is no quick fix about it. There is good engineering. So let's do good engineering. So first of all, vulnerability management, or the modern vulnerability management, is application, infrastructure, and cloud security built all together, because there is no anymore boundaries between those things. And any organization that keeps on saying there is a boundary, there are teams, there are different time and different methods to fix these things, it's a lie. Because as a hacker, I don't care if I'm going to attack the application, the supply chain, or the box where that thing lives. I'm going to find the easiest path to reach that problem. And I'm not going to argue with management, but Joe from platform team hasn't patched the container because he didn't know that that particular vulnerability was included in the container that was coming from a piece of software that was an open source organization. Again, who does what where? And the answer is, as well, the first part of the answer is prioritizing is not that hard. We have a very simple way. So if we take the whole list of vulnerability, the one that are really important is just 5%, 1%, your opinion, the one that actually are well known, 25,000, the one that we see on average on our clients. So it's not anymore that scary number of 263,000, because that's included things from 1993 onwards, vulnerabilities. So we don't care about those. The only one that we care about is 25,000 vulnerabilities that are currently active in the wild. And of those, a fraction of them are actually exploitable, are actually used in live, are actually reachable. And the one that we need to care about are a single digit. So let's see how prioritizing things in two different landscapes, because I've been keep on saying application security and runtime needs to be correlated together, but they're not the same beast. In order to prioritize things from a software perspective, the important things is, do you have a fix available? Is that particular problem reachable? Is that particular problem or library deployed anywhere? Those are the important questions to ask when prioritizing software supply chain vulnerability or any vulnerability in a particular piece of code. What in a cloud environment do you have a fix? Is that thing deployed in prod? Is that thing exposed? Is that part of a container skill set? Is that container even running? Those are the important things to ask your vulnerability management program. And if you don't have a vulnerability management program that answers those questions, you have a spreadsheet. And throwing a spreadsheet to an LLM will not solve your work because it doesn't have the intelligence to look at things. So if you want to take a very simple answer to what's exploitable, what are the vulnerabilities that we need to take care about, if you just look at the bug bounty active vulnerability, those are 17,000. So we go from 26,000 to 17,000. GitHub active and verified exploit, that's 9,000. Those are not the hidden zero-day vulnerability, but those are the low-hanging fruit that anybody with an automation will try to throw your system. So if you have one of these, please don't burn your money on bug bounty on those things. Please don't give this away. Just throw a scanner, identify an important one, fix them, and then focus on the bug bounty and other things that only people with intelligence or eventually LLM in the future co-find. If you go down the line again, verified exploit, CISA-CAV, who heard of CISA-CAV or VUNCHE-CAV or manually verified exploit? Those are good CTI. Those are good elements. Include them. They're freely available for everybody. EPSS above 0.36 right now because we updated to version 4 and we made it a little bit faster with data and intelligence. Those are, it's the threshold that we say that a vulnerability has actually the probability of exploitation in the wild in the next 30 to 14 days. And then, is that asset reachable? Is that asset exposed anywhere? And reachability is going to have different terms. So when you look at the exploitability, who has a definition of exploitability in the room? Who can tell me what's a vulnerability that is exploitable? What does that mean? Do we have a single answer? Reachable is one? Sorry? Easy to break in. Yes, you have a well-known exploit available in the wild. Is that being used? All of the above. All of you are right. So is that popular? You have some free and open source available option to see if a vulnerability is popular. Was this a 0-day? Likely is it's going to become an exploit. Is this automatable? You can look at your attack vector if has specific characteristics. And that's where LLM are excellent. And we're going to see an example of how you can use one of the LLM agents that we have to calculate prediction above and beyond EPSS. Is it exploitable? Is it exploitable in the wild? Do we have evidence of that? Do we have good available CTI? All of this will drive down your vulnerability exploitation. There is reachability analysis that we're going to cover on one in a second, because some of this information are not applicable for SCA and container vulnerability. So we need to look at the problem of container vulnerability and open source software being built in container in a slightly different way. Also because of scale. So if you want to impress your management team, you give them a pyramid of metrics that you can use. So if you're maturity level 0, you just react on what the scanner says, on CVSS, on basic metrics. And then you're going to start evolving your metrics. You're going to start looking at severity. You're going to look at actual exploitation. You're going to look at the stuff that is actually reachable. So you mature your organization. I'm not asking you to go away from this session and say, we're going to be the most mature organization in the world from tomorrow, because any management team was going to laugh at you. But you're going to build a roadmap to a certain level of evolution. Because we want to move from raw vulnerability data to enriched vulnerability data with context and with reachability, because that we can feed to an LLM. So, big question to you. Come on. Can we use LLM now? No. It's ownership time. So let's talk about ownership, because what's the point of prioritizing if we don't even know who owns that asset? Where do we raise that vulnerability? Who's going to fix it? Joe from platform team or Dave from software team? Well, if nobody knows who owns that specific box, everybody's going to point the finger at the ceiling and say, let's figure out who owns this. Guys, who owns this container? Like, in the meantime, the container get exploited or the software get exploited. Like, that needs to be solved before a vulnerability happen. Owning the right problem to the right team is a very important problem. And we have way to do that. So the way to do that is, again, thinking about context and thinking about left and right. So who owns the platform sometimes is a different team that who owns the software in the left, and software has different stage. So answering the question, who owns a container, is a very complicated question, for example, because the container could be the OS, the base image that get generated, that could be platform team. The software that runs inside the container, that could be another team. So it's a complex scenario. And if we raise SLA for a vulnerability in a container that the platform team can't solve, we're just gonna annoy them, to just be polite. And the other way around, if we raise a vulnerability of a cloud solution that the software team can't do anything about it, we're going to annoy them because they can't do anything about it. And you know what they're going to call that? False positive. And it's going to drive us mad from a security perspective, because that's a true positive, but it's just false attribution. So we also need to teach developer to tell us we don't have a good CMDB. And as a security team, unfortunately, are forced to tell them, well, tell me what you own. And they're going to say, well, I don't know. So that's a conversation to be had before or with your vulnerability management program, because anything that doesn't have ownership in a vulnerability management program is going to just create nice, pretty dashboard that are giving you prioritized vulnerability, but they're not actionable. And no LLM in this world can give you that. It's a collaboration between security and engineering. Again, I'm here to demystify and not give you magic security dust. If you want, I have 3. You can try to sprinkle on your SCA or your dust and see if you can find vulnerabilities that are actually exploitable, fixable, and owned by a specific team. Believe me, you don't. But you can try. So I'm going to go quickly through this, but basically understanding how a software supply chain is created, how a specific software, which app gets built in which container, which library get loaded in which particular base image that get loaded in where, is the answer you need to answer, for example, on container vulnerability and SCA vulnerability. And that's even more important if it's exploitable, because if it's reachable, highly likelihood that that vulnerability is going to be exploitable. And this is a very hard problem to solve from an engineering team. As soon as you give an engineering team an SCA vulnerability or a container vulnerability, he needs to do this similar diagram to understand, do I even own it? Is it coming in the container? Is it coming from the base image? Is it coming from the repository? And who owns the repository? And understanding which app is built where, or is it in the image the problem? Is it in the base image the problem? Is it in the origin that I'm download from a specific repository somewhere else? Or is it in the build where I include my SCA vulnerability or my open source vulnerability? Every time we raise a container vulnerability or an SCA vulnerability, this diagram needs to appear in the head of a developer. And if it doesn't, he needs to build it. And that takes hours. And that takes a lot of investigation. That takes a lot of decompiling, especially if the container has been already built. That's where we specialize with Phoenix, and that's what we obsess, because that's an answer that prevents burnout. Understanding who does what where and trying to separate the left from the right or making it seamless is what saves engineering and security a lot of fight. And then you can start talking about SLA. I'm not going to go to the detail. We can maybe discuss in the break an example of that and how the 4 reachability analysis exist. And for the first SCA vendor or any vendor that's going to come to you and tell you, we have reachability analysis, just to annoy him, ask him what of the 4 reachability analysis you have. Which one of the 4? File level reachability analysis, build level reachability analysis, container to cloud reachability analysis, network reachability analysis. Just to annoy it, just to make the SCE work a little bit harder. So let's talk about LLM. Let's talk about AI and how we can take a basic risk approach to vulnerability and how we can tie all these together. So the question you want to answer is really, how do I go from tons of vulnerability that I have to the one that are exploitable, weaponizable, actually reachable, deployed to production, and actually important? That is the funnel that you need to look at. And then basically go from a very basic CVSS, that's where most of the organizations start the journey in vulnerability prioritization, to a journey where you consider likelihood of exploitation, reachability, and business criticality. These are the answers that you need to answer to say, what is the risk of a particular problem that I have? And looking at your work, still look at which business application you build and where you deploy it and who owns it. That's the other answer that you need to answer with a vulnerability management program or tool. And all of the things we discussed can feed into risk. So we're not reinventing the wheel here. We're just trying to answer with a single number, or with maybe a couple of variations of that number. Is that problem something we need to consider, or we can cancel it and say no to that particular problem? That's a very hard thing to say in security. Don't look at that. We're very good at saying, look at that critical problem. We're very bad at saying, don't look at that because it's not reachable, it's not exploitable, it's not there. That's why nobody likes vulnerability management, really. And what impact does it have? And that is the context. So with that, a data modeling time, or LLM, as other people talks about. So a little bit about how we approach this problem. We haven't approached this problem in any other different way that human would approach this problem. So we look at the problem of we need to have the right data to understand a vulnerability. Is it a problem or not? That's the first agent that we have. Then we're gonna just look at all of the context with all of the vulnerability that you have in a particular deployment scenario on a good data set where we have already done prioritization, contextualization, and so on. And then in this scenario, can we exploit it? In this particular situation, can we exploit it? And then at the very end, what is the best path to remediation? So this is what normally goes into the head of somebody looking at a set of vulnerability and understanding or trying to analyze, is it important? Is it mine? Is in this particular context exploitable or not? And then how do I fix at scale? Otherwise, we're back in the middle age and reacting on any single vulnerability that comes at us. And on some way, if you have a very small code base, it's way easier to actually just fix all of the problems as soon as they come up. But as soon as they become in the hundreds of every release, as soon as the code base becomes bigger, go in this journey. I'm going to just quickly touch on how we deploy the agent. So the researcher is going to spit out a vector of analysis. That's where we apply an LLM, because LLM are really good at understanding CTI intelligence and creating a vectorized information of vulnerability that then we can use in the next agent that can tell us the root cause analysis, particular threat attack scenarios, and then finally in the remediation agent, we can look at, hey, in this particular scenario, how do I fix it? What is my best path to remediation? Do I fix the container? Do I fix the library? Which is the library that's going to give me the biggest bang for bucks? And if I can't fix it, can I deploy WAF rule or any rule that's going to enable me to do virtual patching? Only if that thing is actually running behind a WAF. So that is why the context is important. All of this is LLM, but LLM applied when we have the right people that knows the right context, that where we can tell to the right people, this is what you need to fix. There is no point of raising a WAF rule to a software engineer that doesn't have access to the WAF. So the three problems that we explored before are absolutely mandatory before we apply any LLM. And don't believe any other company that tells you LLM is going to fix everything else, and then we're going to apply the whole context, prioritization, attribution, because they're only going to try to solve one piece of the puzzle that is the last piece of the puzzle, not the first one. This you can even forget. You don't need this. But the first part, you need. Prioritization, attribution, you absolutely need. This is just to accelerate vulnerability resolution and to help engineering team to 10x their time. But you need the first part. Otherwise, who are you going to raise the vulnerability to? Is that vulnerability even reachable? You've done an analysis of 300 vulnerability in a container that is in a repo or in an image or in a registry that is not even running. What's the point? Right? Why are we wasting tokens in an LLM to do an analysis that doesn't matter? And I know it sounds boring. I know it sounds not cool, but I'm trying to save you money and time and reputation, because as soon as we start telling engineers another answer, another false positive answer, we erode credibility. And that's what's hurting DevSecOps or security talking to engineers. We need to talk with clean data, and we need that collaboration to have clean data. So can we use AI now? Yes, we can. So what we did with the first problem, the researcher, is looking at, for the vulnerability where we don't have reliable data, can we understand the DNA characteristic of vulnerability that's going to turn into a ransomware attack, an exploitation? What are the things that turn something into an exploit? What are the patterns? What are the characteristics? What are the DNA analysis? Is this kit going to turn bad, or is this kit going to turn right? Right? So first of all, we need to solve a problem. It's a data problem. And we don't have enough data about vulnerability. We have CV data, and then we have CTI, and we don't have anything in the middle to link these two things. So We take CV, we go to MITRE through CWE, root cause analysis, threat impact, CAPEC, TDP, and then we're going to lead to threat actor. Those are basically trying to simplify this diagram. We're looking at the CV, the vulnerability. What are the characteristics that this vulnerability has that threat actor is going to use? And then we start looking at, are there any characteristic of this vulnerability that are more likely to be used in particular data set? And it's going to become very apparent in a second. Now, CVE we have for container, we have for SCA, but for our code, we have CWE. So this methodology enable us and anybody that use this methodology to basically take a CTI-based or a threat-based approach, regardless if we're talking about patch a server or my code is it going to turn into something that's going to be exploitable. So it gives a single language of exploitation. And this is what in security we've been talking about since forever. So an example of this journey is this one, and I'm going to give you access in a second. So if you want to test it, we are the only security company that has made their LLM and their agent available. So you can test it before you buy it. I'm joking. Yes, it's open source. You can throw basically vulnerability, your threat modeling, your threat attack description, and all of the vulnerability that you have, and it's going to spit basically the attack vector and the enhanced description. And we want to be able for everybody to start talking about this. And the only way we could do it, open source it. Have a play about it, capture the link, the book, explain the journey, the methodology, and the data set that we used, that I've used to actually guide the research team. This is a shared research right now with the North Carolina University. We have a couple of PhD working on it, plus Yahoo team. And we're going to make a little bit of this open source available. So we're going to enrich, and basically we rewrote the entire MVD to fill the gap of that 50% of vulnerability that weren't basically categorized with methodology of attack. And fundamentally what we did is, can we create a data set of common vulnerabilities similar to OWASP top 10 that enable us to characterize the vulnerability in the MVD or whatever we can see? And then we said, in the National Vulnerability Database, or all of the vulnerability that we have available, what are the common characteristics? If you look at on the right, they're fairly distributed. So we don't see any pattern appearing. So we start looking at, is the pattern between different years going to change? Yes, we start seeing the distribution of problems start changing. Cross-site scripting is basically slowly going away as a problem. Remote code execution is staying, but denial service is slowly going away. And then we answer the very important question. Can we apply this to ransomware? So we took zero-day vulnerability, or the well-known vulnerability that's been disclosed, bug bounty, ransomware attack, and say, out of this, what are the trending, what are the patterns that are more frequent? And at this point, we start seeing pattern emerging. Remote code execution is something available and reachable from external and from remote. Can I execute code? Yes. Buffer overflow, can I bridge basically gap in memory that's going to enable me to move between programs and maintain persistency? By the way, all of this data is available to play. So we publish all of the data behind this intelligence on the website. So go and play with all of the data set we have available through our CTI. But fundamentally, we start seeing as well, 0 day was probably, remote code execution is very apparent throughout all of the years, throughout 0 days. And then we start asking the question, ransomware attacks. First of all, what is the frequency of ransomware? And can you notice who has the biggest attack surface? Which vendor has the bigger attack surface? Microsoft. Why? Because everybody's using it. Everybody has a Microsoft product. So as a ransomware attacker, I'm going to develop the version for Arch Linux, or I'm going to develop the version for Microsoft Windows. So programs and these are actually, we actually embedded that in EPSS. So if you have a particular program or if you have a particular version, those tags are actually part of the EPSS dataset, and we use the same logic as well here. But I want you to focus on the right side. Again, we start seeing the memory corruption and the remote code execution as pattern appearing. And over and over and over. So basically we took this and saying, can we use this as a prediction scoring or as a way to determine which threat actor is using which methodology, and created basically a data set that enable us to predict which vulnerability will lead into a ransomware or into a potential exploitation together with all the other factors. So we did this with LLM because this is a classifier problem, and LLM are really great at looking at a big data set and reclassifying those vulnerabilities into something that has a lot of context. This is where you use AI in the proper way. And this is the work of the researcher that's going to enable you to create, basically, regardless if you have vulnerability without this information, this creates this information. And we can use on CTI. Now, one interesting thing was bug bounty, where we had divergence. And bug bounty has maybe a biased approach where the common vulnerability normally are not being published as part of the bug bounty, but the really hard one to find are published as this bug bounty. But that's the only data set and the only place where we saw divergence, where we didn't see a pattern appearing as the other pattern that we've seen in the other attack, like remote code execution on CISA-CAV or verified exploit, or all of the GitHub with an exploit available and verified exploit. Again, remote code execution appearing over and over. So in conclusion, I hope you start creating a more critical thinking about LLM. We can discuss more about throwing all of the vulnerability and what the result of those vulnerability in an LLM is and how those are gonna point you to the very wrong direction. So what I want you go out of this talk with, in a way, is use LLM and AI in the proper way. And for every company that come at you and say, we have the answer is AI, just call it BS. Thank you very much.
Thank you very much, Francesco. Right. Thanks for an awesome talk. Right. I think we have time for one question before we go into pizza. Anyone has questions? No? Okay.
Isn't the problem with Microsoft that it has a heritage of DDoS, which apparently stands for down and dirty operating system?
Well, Microsoft has an enormous attack surface to maintain and a lot of legacy software to maintain. And no matter what you're trying to decommission, airports still use Windows 95. And they pay a lot of money for those versions to be maintained. And regardless if Microsoft doesn't maintain anymore, another software house will try to maintain it and patch it and do something about it, because it's really hard to unhinge this software from specific system, unfortunately. Yeah.
One second, I'll bring you a microphone.
But I mean, don't you think that, for example, over time, Microsoft, even though they're trying to maintain like as much as possible, they become, in some ways, in some areas of cybersecurity, they've started to become a little bit complacent sometimes. Don't you think so?
No, I think they got way better. They got so much critique, they got so much attack surface that they got a lot better, but they have a lot of surface to target. So they're getting better at publishing vulnerability. They publish 70, I think, fixes every week or so. Patch Thursday is a thing. And we got way better at patching things. Right now, the attacks that we're seeing, Log4j, Spring4Shell, TJ Action, all of these are coming not from patching, not from Microsoft, but from other attack surface, because luckily we got better at fixing and patching things or automating that element. The problem that we're facing right now is container being built from somewhere else, because that's the next frontier of the hard things to solve and do. It is first party. As soon as you adopt it in your codes, I think it's first party. I think it's your problem. It's third party library, but as soon as you download it, I still consider it as part of my code. Yes.
Thanks very much, Francesco.